Well, we're doing question 1.1 that says solve for x. And in the previous videos, we did question 1.1.1 through question 1.1.3. Now we're going to do question 1.1.4. The question says 1.1.4. The question says x minus 3x to the power of half equal to 4. And then we need to solve for x, find the value or values of x. All right. We have an exponential equation here because we have an exponent on top of exponents on the variable. Okay. So now what we can do, okay, let's solve the equation. I'm gonna write here. We have like x minus 3x to the power of a half equals to 4. Now we can solve this if by introducing another variable. Let's say let n equal to x to the power of a half. Okay. So if n equal to x to the power of a half, then therefore, instead of me writing x here, I'm gonna write n squared. I don't know if you see that. Okay, because don't notice if n equal to x to the power of a half, this means that I'm gonna write here like this: n equal to x to the power of a half. This means if I set it, if I raise it to the power of 2, for instance, I raise it to the power of 2, to the power of 2 both sides, power of 2 and power of 2, then that means n squared will be equal to x, because over here the exponents can be cancelled, and then I have like x to the power of 1, which is n squared. Okay, so now because over here we have x, it means x can just be written as n squared. So over here I have n squared, so it'll be n squared minus 3n. Okay, because n we did set that n equal to x to the power of half equal to 4. Okay, over here I wanted to move 4 over, so that minus 4 equal to 0. So we see that this minus 4 equal to 0. Okay, the idea was to transform that equation into a quadratic equation, because with a quadratic equation we can easily solve it. We can solve it by factorization, or we can solve it by using the quadratic formula. In this case, I prefer to solve the equation by factorization. So what I can do then, I will consider the last term. Okay, I will consider the last term first, which is negative 4. I will write here over here negative 4. Now I list all the factors of 4. They are like 1 and 4, 2 and 2. Okay. Now I will look at the list of the factors of 4. There must be one couple, exactly one couple, which will make a sum equal to negative 3. Negative 3 is the coefficient of the middle term. Now let's see. With 2 and 2, we'll never get negative 3, but with 1 and 4, yes, we can, if we have a positive 1 and negative 4. And of course, positive 1 times negative 4 will make negative 4. Okay, so over here in the bracket, I can just write n, close bracket, n, close bracket equal to 0. Then I place in positive 1 and negative 4. So according to the property, the multiplication property that says a times b equal to 0 implies that a is 0 or b equal to 0. I'm going to set n plus 1 equal to 0 or n minus 4 equal to 0. Then we have n equal to negative 1 or n equal to positive 4. Then remember, we were not supposed to solve for n, we were supposed to solve for x. X was set to be equal to x to the power of half. Now I can substitute the value of n, which is x to the power of half. So this means x to the power of half equal to negative 1 or x to the power of half equal to 4. Now if I need to find the value of x, then what can I do? I will raise this to the power of 2, and then that also to the power of 2, and this to the power of 2, and that also to the power of 2. Excuse me. Then, excuse me. Okay, before I do that, I was about to miss something here. X to the power of a half equal to -1. This part here is not applicable, okay? Because it cannot generate exponential numbers regardless of the value of x. It will never be a negative answer, negative number. No, this is always positive. The reason is, I'm going to write here, since x to the power of a half is always positive or 0. Okay, and then over here, then is where I can solve if I set it to the power of 2, and that also to the power of 2, and then we will have like x is equal to 16. Why am I setting that to the power of 2? Because I know this property that says a to the m all to the n. This is equal to a to the m times n. Okay, and then when I times this, we can just simplify the 2 and the 2 here, have x to the power of 1, which is 16. X to the power of 1 is just x. X is equal to 16. Thank you.